Hello everyone. Today I'm going to talk to you about the business value of tokens. I have salespeople that boast that new features needed twice as many tokens, which apparently makes them better, while engineers take pride in delivering their features using fewer tokens, right? So we need a way to quantify the business value of tokens similar to what we did with the cost per streaming hour in the past, right? Um, Here, John Kim from Payloop is the one that encouraged me to do this segment, and I want to thank him for that, right? First thing that I want to do, let me see if I can make this work. There. If you don't have anything, start with tracking the cost per million tokens over time, right? This is analogous to cloud spend per revenue. So the vendor is giving you an invoice, right? The invoice has a dollar value, it's pretty straightforward. And then the vendor will also tell you how many tokens you used, right? So you simply divide those two by each other and you get the cost per million tokens. And ideally, this should be trending down over time. And let me expand on this. For us, the cost improved from about $1.55 per million tokens in October 2025 to $1.02 in June 2026, right? This means that we are getting more efficient with model routing and caching, and I'm going to talk about that in a bit, right? Even though the latest generation large language models are getting more expensive, right? At this time of the recording, it is Fable, Mythos, the latest OpenAI, those kind of models are getting more expensive, right? So next, if you have more data available to you, right? If you're able to track active users over time, you can now calculate the average AI spend per user. We currently have a mandate to increase AI adoption, where understandably this KPI is growing, right? And it grew from $23 per active user in October 2025 to $417 in June 2026, right? Once the adoption stabilizes, we can then use this KPI to measure efficiency as the same work is performed at a lower cost point. If you can get AI spend per specific user and or service, you can now build finer resolution breakdowns. For example, we offer an internal website where employees can ask questions about sensitive data, things that shouldn't leave the corporation, the organizational boundary, right? You don't want to ask about your revenue numbers in a public, large language model interface like Claude or ChatGPT. So this internal website was responsible for 67% of all of our AI spend last month. Cursor came in at 15% and Claude came in at 6%. This means that 21% of our AI spend is on writing code, which is an interesting data point, right? That this KPI makes possible. Another finding is that our top 25 engineers are responsible for 16% of our AI spend. Um, this can be a good thing, right? I like it, but something that you can track over time. Out of around 4,800 employees, only 73 have never used AI, right? So that's also interesting, and you can take a look at who those people are, in which areas they are working on. And something that I'm currently investigating is why is 6% of our AI spent on weekends, right? So I have detailed graphs and there is residual spend on AI on weekends. And it's unclear if this is done by developers working, right? Engineers working on weekends, or if these are just agents that were asked to give a daily summary and they keep doing daily summaries on Saturdays and Sundays when no one is looking at it. Next one is that some business units will already track internal KPIs, things like tickets closed, bugs remediated, features released, those kind of things over time. Um, these will generally trend upwards as engineers are able to use AI to save time, right? They will be more productive over time. One team who volunteered closed between 7 to 17 tickets per person per week in October 2025, and this increased to 13 to 21 tickets in June 2026. So we are looking at a 42% productivity increase due to AI, which is great. This is fantastic that we have that point, right? Using the average AI spend per user, we spent about 48 cents per ticket last year versus $6.13 this year. Granted, these are still very early numbers, but they will stabilize over time and you can use them as an API to track things. Now comes something that is probably a little bit more controversial. And this is because engineers can inflate the metric, lines of code per 100 tokens, by adding unnecessary comments to their code, right? They simply prompt the large language model to go ahead and provide lots of comments to make the code more readable, right? The following that we are going to go over assumes this is not the case, right? So they are not doing any of these types of inflations of this metrics. Engineers used on average about 102 tokens to produce just one line of code in October 2025, and this number improved to 51.81 tokens this year. Of course, this is a calculated average number, right? 51.81 tokens. So it's about maybe 2 lines of code per 100 tokens. And as AI improves, this number will reduce over time, and we are going to do a summary at the end. We can now also convert tokens to lines of code should this be useful in some way. For example, the $6.13 per ticket from the previous example is worth around 120,000 lines of code. And the average AI spend per user of $417 per month is worth around 8 million lines of code. So if that is desired, you can always convert tokens into lines of code and lines of code into tokens. Now, a pull request is where a contributor asks a maintainer to pull their code into a code repository, right? And we are talking about the pull requests per engineer. While this is very similar to, let's say, tickets over time, this KPI is sufficiently important to be called out separately. Our number of pull requests increased 4x to 7x, depending on how much the engineers use AI. The code submissions tend to be smaller, which makes them easier to review. However, there's a considerable increase in requests prompted, and that prompted us to switch to AI to review the requests. So yes, AI engineers use AI to generate code, and then we use AI to review the code. However, the AI will review the majority of requests while delegating hard-to-judge cases to people. Engineers, as a result, report that code reviews became more mentally stimulating as all the basic requests have been automated. So that's an interesting learning. Next, we have a technical KPI, which is the cache hit rate. This is the percentage of user requests answered using stored data rather than being sent for full inference. This technical KPI needs to be tracked over time to measure efficiency and savings. For example, our cache hit rate improved substantially from 19.35% in October 2025 to 81.36% in June of 2026. This tells me that people are asking follow-up questions about the same data. A good example here is engineers iterating on the same code base, right? So the code base stays in memory, it's cached, and they are making improvements over time. If you are able to get the cache hit rate per user, this will also allow you to identify users working on novel concepts or on things that cannot be cached. Interviewing these users will provide insights into how AI needs to be adapted to improve their activities, right? So they are working on something that is vastly different than other people, and there will be ways on how AI can help them. Next one is the tokens per hour. The previous KPIs are measured in, let's say, weeks or months. I mean, you have hourly data, right? But you typically present the hourly data in aggregated fashion, and you will typically present it on a weekly or monthly or quarterly basis, something like that, right? And the idea of the previous KPIs is to track improvements over time, and we are going to take a look at in just a moment at what good looks like and how they should be trending. However, for fast anomaly detection, you need to look at tokens per hour. You calculate a dynamic confidence band per application, team, or user, and alert if the number of tokens exceeds this boundary. The most common cause for this runaway tokens is loop engineering. Loop engineering is where agent systems iterate tasks autonomously. If an engineer didn't provide a stop condition, it is possible for the system to iterate indefinitely while using tokens at an astonishing speed. So, in summary, what I promised before, when using tokens as a unit of measure, it is important to be aware of the inconsistency in the quality of output. This is influenced by the quality of the models, which in turn improve over time. There's a website called Artificial Analysis, which is just the word artificialanalysis.ai, that helps to understand which models perform best in which areas. Here is the summary of the KPIs and how they should be trending over time, right? So we mentioned at the very beginning, cost per million tokens. A good value is somewhere around $1, and the trend should be downward over time. The lines of code per 100 tokens, that a good value for that is 2 lines of code per 100 tokens, and the amount of lines of code should increase over time, so the trend should be upwards. And the cache hit rate, a good value is 80%, and again, this cache hit rate should trend up over time. That's all I had today. Thank you so much for watching. If you guys have any questions, you can either reach me on LinkedIn, where I basically answer your questions right away. There is a similar post. Of course, it's not the video, it's going to be an article where you can reply to that, or you can simply email me at info.matzion.com. Thank you so much for watching, and I'll see you guys soon in a bit. Take care.